This is part 5 of section 3.4. We want to find all of the zeros of this polynomial function. It is a 5th degree equation. I expect 5 answers. Let's look at Descartes' rule of signs. So how many positive solutions might I have? I need to count the number of sign changes here. Positive, positive, negative, that's 1 sign change. Negative to positive, that's 2 sign changes, positive. So I either have 2 or 0. Now let's look at f of negative x to find the number of potential negative solutions. Remember, this changes the signs on everything with an odd exponent. So I'm just changing the signs above it so I can just look at the pattern. This will be negative, positive, positive, negative, negative, positive. Changed everything with an odd exponent. So how many sign changes do I have? That's 1, 2, 3. So I have 3 or 1 negative real solutions. Okay, so let's figure out our P over Q. Our p-values come from 24, and this is fairly large. It has a lot of factors. So things that just divide evenly into 24, of course, plus and minus on all of these. 1, 2, 3, 4, not 5, 6, not 7, 8. These pair up. 8, this will be 12, and then 24. My Q values come from 4. So this would be 1, 2, and 4. Now let's list all of our P over Q values, and this is going to be a lot. Just get yourself in a groove, and you need to think about, how these fractions reduce as we go along. You don't want to duplicate potential solutions. 1 over 1 is 1. 1 over 2, 1/2. 1 over 4, 1/4. 2 over 1, that's 2. 2 over 2 is 1, which is already listed. 2 over 4 is 1/2, already listed. Okay, now we're at 3. 3 over 1, that's 3. 3 over 2, 3 over 4. Okay, now 4 over 1, that's 4. 4 over 2 is 2. 4 over 4 is 1. 6 over 1. 6 over 2 is 3. 6 over 4 reduces to 3/2. 8 over 1. 8 over 2 is 4. 8 over 4 is 2. 12 over 1. 12 over 2 is 6. 12 over 4 is 3. And then 24 over 1. 24 over 2 is 12. 24 over 4 is 6. So that's all of our possibilities, and it is a lot, but compare this to potential infinite number of solutions, and it's much better. Okay, so we just need to make a guess and go with it. I've started off checking positive numbers on the other ones, so I'm just going to start off with negatives here, especially since I know I have at least one of those. Now, I might not have any rational negative solutions, but there's a decent chance I do. So let's just start off with -1 and see where we end up. Write down your coefficients here. They are all here. Nothing is skipped over. So 4, 12, -41, -99, 10, and 24. Bring down the 4. If I check 4 times -1 is -4. I add, I get an 8. Multiply, that's a negative 8. Add, you get negative 49. Multiply, you get positive 49. Add for negative 50. Negative 50 times negative 1 is positive 50. Add to get 60, and you have negative 60 here. I'm checking a negative number. I do not have alternating signs, and this is not 0, so negative 1 does not work, and it does not eliminate anything else. Okay, let's try a negative 2. Using these same values, since this did not work, bring down your 4, multiply to a negative 8. 12 plus negative 8 would be positive 4. 4 times negative 2 is negative 8. Add here to get a negative 49. Negative 49 times negative 2 is positive 98. Add here for a negative 1. Multiply for a positive 2. Add for a 12. And then multiply and you get negative 24. So that's a 0, and negative 2 is one of our 5 solutions. Okay, now check here, since we were checking a negative number, check for alternating signs to see if we can eliminate anything else, and that didn't work for us. Okay, so let's look at what we have here. We have one of our solutions, which means we've simplified what we have left here. This started off with a 5, so this is a 4. And so what this goes to means that the new equation that I need to solve is 4x to the 4th plus 4x cubed minus 49x squared minus x plus 12. Okay, now let's rethink our p over q, and it's going to be nicer because we know we are dealing with a smaller number now for this part. My p-values, I'm going to, comparing this to this, what's the big difference? Well, I still have a 4 here, so my q values are the same. My p-values, I still have a 1, and I'm going to have up to 12. Well, I'm going to eliminate some of these. Let's just look at our p-values. Okay, things that divide evenly into 12. That would be 1, 2, 3, 4, 6, and 12. So it eliminated the 24 possibility and the 8 possibility. Now all of my p's over q's, which are the same as here, my q values are here, so I'm just not going to recopy them. My new p over q possibilities are 1 over 1, 2 over, 1 over 1, 1 over 2, 1 over 2, plus or minus 1/4. And then I have 2 over 1. 2 over 2 is 1, 2 over 3, 2 over 4 is 1/2. So basically I've used this, 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 and then I have this one. I still have the 3, so I'm going to get all of the ones involving a 3. So 3 over 1 is 3. 3 over 2. So I have that one and that one. I have 3/4. Okay, I have the 4 still, so I have 4 over 1. And then 4 over 2 is 2, 4 over 4 is 1. I have 6 over 1. Okay, and then 6 over 2 was taken care of, 6 over 4 was taken care of. I don't have an 8, so I don't even have that as a choice anymore. I don't have the 24 as a choice. And then I have the plus or minus 12. Okay, now notice here that I checked -2, but -2 is still a possible solution. it might be that I get this answer twice. So that might mean I need to check it again. And this is why you don't want to just plug in these numbers and see if they work. Because I plug in -2 up here, I'm going to get a 0 every time. But I may or may not get it twice, and I will never know if I'm just plugging it in. So let's just make another guess here. I checked -1, it did not work, so -1 is not going to work here either, because it would have to be a solution of one or the other, and if it's not a solution to the big one, it's not a solution to the small one. So I checked -2, I did not have alternating signs, so let's just check -2 again, since it's still a possibility. If I check -2 again, I now use these coefficients. So I have 4, 4, -49, -1, and 12. Bring down the 4. Multiply, that's a -8. Add for a -4. Multiply for an 8. Add for -41. I do not have alternating signs, so that's not going to help me out this time. Multiply here, and you get 82. Add for an 81. And this gives me -162, so this did not work. So that tells me -2 is not a double root. Okay, so let's try -3 and see if it works. I'm using these same coefficients here. Bring down the 4. Multiply, and you get -12. Add for -8. Multiply 24. Add -25. Multiply 75. Add 74. We do not have alternating signs here, so that doesn't eliminate anything for us. Multiply, and you get -222, which is not a 0. So -3 did not work either. Okay. I'm just checking my integers. I'm avoiding the fractions because we all like to avoid fractions, right? So I'm going to check -4. Oh, I'm using the wrong values. I should use these. -4 is 4, 4, -49, -1, and 12. Bring down the 4. Multiply for -16, add for -12. -12 times -4 is 48. Add for a -1. Multiply for 4, add for 3. Multiply, you get a -12, and you get a 0. Okay, so -4 is another solution. I now have how many of them? I have 2 of my 5. So far, I know one solution is a -2, and I know -4 is another solution. Okay, now I need the rest. So I had a 5th power. When I found one solution, it dropped down to a 4th power. I found another solution, so this drops down to a 3rd power. So I have 4x cubed minus 12x squared minus x plus 3. This is now what I need to solve. And since our last number is even smaller than it was here, we could do the P over Q thing again and reduce the number of answers we need to check. Now, we know that in general, we cannot solve a cubic. We can solve any quadratic, and we can solve other things that are quadratic in form, and this is not quadratic in form, or that factors by grouping. And when I look at this, I see that I could factor a 4 out of this. And when I factor a 4 out of this, I'm just glancing at it, I see I'm going to get a 3. So I'm going to try factoring by grouping. If I group these first two together, and I could factor out a 4x squared, and that would leave me with x minus 3. And then if I group these two together, and I factor out a -1, I will also have x minus 3. equals 0. So that means this factors as x minus 3 times 4x squared minus 1 equals 0. And I can solve this. One of my solutions is going to come from x minus 3 equal to 0. And that just gives me x equal 3. 3, was that one of my original possibilities? Yes. Okay. I have 2 negative solutions so far. I just added another positive solution. Now from the very beginning, I should have 3 negative solutions and I should have either 2 or 0 positives. I know it's not 0 because I have at least 1. Now the other 2 solutions, I know I should have 5, come from 4x squared minus 1 equal to 0. Now I could solve this as a square root property problem, but this is a difference of squares, so it factors easily as 2x plus 1 times 2x minus 1 equal to 0. Set each of these equal to 0. And when you solve this one, you get negative 1/2, which was an original possibility. So negative 1/2. And that brings me to my 3 negative solutions. And from here, you'll get 1/2 exactly, which gives me my second positive solution. This is it. Okay? This is just about as ugly as these problems get.